Hello everybody, this is paper 1 from May 2023. This is time zone 2. Okay. Part 7. Annie owns 4 cafes represented by points A, B, C, and D. Annie wants to divide the area into delivery regions. This process has been started in the following incomplete Voronoi diagram, where 1 unit represents 1 kilometer. The midpoint of CD is 5.5, 1.5. So the midpoint of CD right here is 5.5, 1.5. Show that the equation of the perpendicular bisector of CD is y equals negative 3x plus 18. So let's go ahead and draw a line between, I'll use a different color, the line between C and D. We want to find the perpendicular bisector. That is to say, the line running through in this case. Perpendicular means, of course, that it's going to intersect at a right angle. We know one point on this line already is 5.5 and 1.5. That's the midpoint. And this midpoint is also going to be critical because our perpendicular bisector is going to run through this point. And if we know one point on the line, all that's left is us to find the slope and the y-intercept using this point. So let's go ahead and work that out. So equation of perpendicular bisector of CD is y is equal to negative 3x plus 18. So let's work this out here. So equation of a line is given by y is equal to mx plus b. Let's find the slope and the y-intercept. Given that we have this perpendicular bisector right here, we know it's perpendicular to this line CD, so let's find the slope of this line CD. So let's say m of CD, just to say the slope of CD. Slope equation is given to us in the formula booklet. I'm going to write it out here. It's y2 minus y1 over x2 minus x1. And so we know point C right here is 7, 2, and we know point D is 4, 1. And if we want, we can put some values of x1, y1, just to simplify things, and we can call this x2, y2 if we want. Okay. And so, hopefully it's still possible to see everything. I'm just going to continue on here actually. So, y2 minus y1 over x2 minus x1. And of course it doesn't really matter the order. We could have easily called this x2 and y2, and we could have called these ones x1 and y1. As long as you're consistent, the order actually doesn't matter. y2 minus y1 and x2 minus x1. So we'll have negative 1 over negative 3, or 1 over 3. You can put this into your calculator, of course, as well. Alright, so if we know that MCD, the slope of this line segment right here that connects C and D, is equal to 1/3, and we're looking for the slope of this line right here, the perpendicular bisector to CD, this one again right here, we know it's going to be perpendicular. So let me actually just simplify this a little. We know that m, we have some m, and it's equal to 1/3. M perpendicular is of course just going to be the top and the bottom rearranged, 3 over 1, and then of course multiplied by a negative. And so our perpendicular line has a slope of negative 3. So y is equal to mx plus b, negative 3x plus b. And now we just need to find our y-intercept. We have 3 unknowns, x, y, and b. But the thing is, we do know one of these points on the line. We do have an x value and a y value that is on the line. So we should be able to substitute. We have this value right here, where x is equal to 5.5 and y is equal to 1.5. So let's substitute that. So y is equal to 1.5 when x is equal to 5.5 plus b. So we've got 1 point on the line, and that's our midpoint. Let's go ahead and solve for b. Actually, what I'm going to do, I'm going to work this out on the calculator. Negative 3 times 5.5 plus 1.5, and it would give us a value b is equal to 18 in this case. So you can work it out through algebra, or you can end solve. So altogether, our equation of a line is y is equal to negative 3x plus 18, and I forgot what it said up here. There it is, negative 3x plus 18. Okay, good. Complete the Voronoi diagram shown above. Actually, sorry, one last comment. For a 3-mark question, chances are they'll want to see calculation of the slope. So, gradient formula, calculation of slope, conversion to perpendicular, and then you'll have a value of b, or simply just our total equation. Or finding the value of b, we know it matches up with this equation. Okay. Complete the Voronoi diagram shown above. Okay. Going to erase this here, and then we can continue on. So Voronoi diagram, what does it do? Let's take one point, for example, right here, this point B, and we see B has these bounds, these boundary lines which enclose it. And what that means is that every single point within this range is closer to B than any other point. This boundary line marks the dividing line where upon either side something is either closer to B or closer to C. At these points we're an equal distance away from BC. These points were an equal distance away from C and D, and so on. So we've got most of our boundary lines already written in, but there's one that isn't. And that is, of course, the boundary line between A and D. This is to say we have D and C, we have B and C, we have B and D, but we don't have this boundary line here. So let's find that out. Coordinate point of A is at 1, 1, and coordinate point of D is at 4, 1. We know that the boundary line is a line which is equidistant from both points. That is to say, this boundary line right here is an equal distance between B and C, and the midpoint, for example, was between D and C. Since these have the same y value, they both have a y value of 1, our boundary line is just going to be halfway through here, and it's just going to be a vertical line. So we can find the midpoint, and the midpoint formula is just given by this. Midpoint is equal to x1 plus x2 over 2, and then y1 plus y2 over 2. And in this case we have 1 plus 4 over 2, and that's actually all we're going to need in this case, and then this is going to be 1 plus 1 over 2. So our midpoint is going to be 5 over 2, or 2.5, and this is just going to be 1. And this is the x value that we're concerned with. So this point right here, where x is equal to 2.5. So complete the Voronoi diagram shown above. We just have this line 2.5. And I think I actually extended a little too far, only going up to there. So we have this dividing line right here between A and D. Since they have the same y values, we're just looking for some x value between, and then it's the vertical line. Vertical lines, of course, just have an equation where x is equal to wherever that line is placed. Alright, Annie opens an office equidistant from 3 of the cafes B, C, and D. So some point in equal distance between B, C, and D. the equation of the perpendicular bisector of BC, that's this line right here, is 3y equals 2x minus 1.5. Find the coordinates of the office. Okay. So earlier they gave us the perpendicular bisector of CD. So we know this equation. And now they're giving us an equation of another perpendicular bisector. So essentially the boundary line between B and C. And we want to know where Annie is going to open this office. That is to say, we want to know the coordinate points of this junction, in this sense, where these boundary lines meet. Because at that point we're equal distance away from both B, C, and D. So equal distance away from B, C, and D. All of these will be an equal distance. So what are the coordinates of this office? Since we have two equations, we want to see where they meet. This is an interesting question. I'll write it out over here. So we have one boundary line. We have the boundary line of CD. And I'm going to represent this as, we can represent this as f of x, or to simplify things, we can call it our equation 1. So we have y1, and that's equal to y equals negative 3x plus 18. And then we have this other equation, and we could have called it f of x and g of x if we wanted to. But we can also call it y1 and y2 to simplify things. But remember, these things actually are equivalent. So we could have said f of x function 1 and g of x and so on. It wouldn't have made a difference. So if we know y2 is given by this equation, 3y is equal to 2x minus 1.5. The question is, where does y1 equal y2? That's going to be where they meet. So this line and this line. If we can find out where they meet, then we'll be good. And so y1 is, now this is going to be somewhat tricky because y1 is already has y on one side, but y2, this second equation, is in terms of 3y. And so that makes it tricky because we can't equate them to each other, not until we, let's say, make a certain move. And I'll show you what that is. So if we're looking at the second equation right here, 3y is equal to 2x minus 1.5. And we want to get it just in terms of y. That is to say, we want to get y all by itself, so then we can set one equation equal to the other. We're going to need to get rid of this 3. What we can do is, if we don't want 3 y's, but we only want 1, we just want 1 y by itself, what we can do is we can divide everything by 3. So let's divide this by 3, divide this by 3, and divide this by 3. So 2x over 3 is going to be 2x over 3. 1.5 divided by 3. This is going to look a little kind of unorthodox, but we can do the same. Just divide everything by 3. And now we've got an equation which is just in terms of x. And then our y similarly is all by itself. And now we should be able to use this. y1 is equal to y2. Alright, so here we go. This is our y1. And it is negative 3x plus 18. And this is our other equation. It's 2x over 3 minus, and let's leave it like this. The calculator will accept it even though it looks a little funny. And now we can find our value of x. And so let's go ahead and then solve. To be honest, it's a fairly elaborate question for only 2 marks. Okay, so let's go back to the calculator, menu, algebra, numerical solve. Negative 3x plus 18 is equal to, and we'll set up fraction 2x, oops, 2x over 3 minus 1.5, whoops, minus 1.5 over 3, and we'll ask the calculator to solve for x. So it's not a nice point, but I think partly is don't really want us to solve this just by looking at it. And so x in this case, going back to the document, x is equal to 5.04545. And to find the y value, we already have an equation in terms of x and y. So what we can do is we can substitute this x value of 5.04545 back into this equation and find the y value. So we'll go back to the calculator real quick and go ahead and do that. So -3, oops, here we are, -3 times 5.04545, and then plus 18. And so we have 2.86. So going back to the document, y is equal to 2.8636. So we'll just leave it as 2.86. Since we're done using the x value, we saved sig figs just until the end, but now we can go ahead and round this up to 5.05, and 2.86. So that should be good, but as a coordinate point it also looks like this, 2.86. And let's see if that is about right. 5.05, 2.86. Just by inspection, it looks pretty good. One thing I was just thinking, in terms of this question, if we want to find the intersection of these two lines, we can do this idea of y1, y2, but I was just thinking of our linear equation solver here. So at the calculator right here, solve system of linear equations, two variables x and y. So linear equation, if we have two linear equations, that means our x value isn't raised to a power of 2 or 3. It's not a quadratic, but if we just have straight lines, equations of straight lines, we can put those into our linear equation solver, and then if it's just in terms of x and y, which it usually is, we can ask the calculator to find the intersection. So this actually, for a 2-mark question, might be more efficient, and it might take less algebra. So I'm going to work it out here as well. -3x plus 18. But here again, it's y is equal to -3x plus 18. And now we have 3y. I'm somewhat doubtful that this will work, but it's possible it will. Okay, so that was actually much, much easier. Jeez. Okay, linear equation solver, put one equation in, put the other equation in terms of x and y, and then it gave us our values just like that. So I was wondering, for a 2-mark question, it seemed pretty elaborate, but just using linear equation solver, linear equation number 1, linear equation number 2, where do they meet? So not bad, actually, not bad.